Hello, everyone. My name is Stephanie Boozer. I'm with CUGC HQ, and I'm happy to welcome you to today's webinar with Liquidware. We're going to be talking about application layering and I think taking a look at the past, present, and future. So that sounds like an interesting title. Can't wait to dig into that. But before we do, just give you a couple of updates on how it's going to go. We are recording today's session and you will receive a link to the recording tomorrow via email. That email will come directly from GoToWebinar, just like your registration confirmation. So be on the lookout for that. Also, we'd like you to submit your questions anytime during the presentation. You have a question panel there, you just type those in and we're going to save all of the questions for after the presentation, but do type them in as you have them so you don't forget them. And finally, at the end of the presentation, I have a very quick link. I'll put in a link to a very quick survey, that I'll put into the chat window for you guys. It's just for CUGC, it's anonymous, and it's just to get your feedback. All right, so let's introduce who's on our call with us today. We have Bart Jacobs. He is a Citrix technology advocate, and he comes to us all the way from Belgium. He's going to keep an eye on those questions for us and handle those at the end. Bart, would you like to say hello to everyone?
Yeah, sure. Hi, everyone. I'm looking forward to it. So let's get started.
All right. So yeah, he'll keep an eye on your questions. So do type those in as we said, and he'll make sure they get those asked at the end of everything. All right, and from Liquidware, we have Matt Boyajian. He is a senior solutions architect. And Matt, at this point, I'm going to hand things over to you. But I think first, before I hand you the screen, we have a couple of quick polls we'd like to run. Just a couple of questions for everybody. Do you want to do those now?
That sounds great to me.
All right, so while you're getting set up, I'll start with the first one. So all about if you've already tried Citrix app layering, so we just like to know what your current experience is. Keep that open just a little bit longer. I feel like I should have the music from Jeopardy.
It certainly would make it a lot more fun.
All right, it looks like most of you have voted, so I'll close that and I'll share the results. Matt, can you see those?
Yes, I can.
All right, so wow, a lot of people don't. All right, and our next question, here you go. Does Windows Network you manage have desktops other than Citrix virtual apps and desktops? Looks like yes is heavily in the lead. All right, looks like most of you have voted, so I'll go ahead and close that out. And there you go, Matt. Yep, overwhelming. All right, well, armed with that information, Matt, I am going to hand the screen over to you. So you can take it away.
Perfect. All right, can we all see that?
Yes.
All right, perfect. So, good afternoon, ladies and gentlemen. My name is Matt Boyajian, Senior Solutions Architect, and today we're going to talk about the past, present, and future of application layering. A couple things before we get started. Number one, I have a tendency of speaking very quickly. So, because of the fact that I'm pretty much going to be talking at you for most of the next 45 minutes, I'm going to try to slow it down today. But if you have any questions, comments, concerns, please use the chat function and ask some questions of your moderator, and we'll absolutely get to those by the end of the presentation. Again, the more questions questions that we have, the more fun this makes it for me. So please ask away whenever you'd like. So we have a pretty stacked agenda today. We're going to be going through an introduction. We're going to talk about where we started in a brief history of something called Absolute, which was the code name for the first versions of FlexApp. We're going to talk about where we are today in terms of our architecture, standard and cloud-based. We're going to talk about why profiles and application layering are codependent. And then we're not going to do one demo today. In fact, what we're going to do is 3. We're going to do a first demo on physical and virtual deployments with application layering as well as profile management. Then we're going to rip all the applications out of that and deploy back to a system using cloud-based applications. And just in case you're curious, I am located in Northeast Connecticut. The applications that we're going to be tying back to are all the way down in Virginia. So we're going to introduce a fair amount of latency as well as distance and see how those applications behave inside of the exact same environment when we rip and replace them. And then finally, we're going to show you how we do this through our application capture methodology. And we're going to go through a couple little demos and show you what it takes to capture an application and why you don't have to be an engineer to capture these kinds of applications. And then finally, we're going to talk about future state. And there's a lot of stuff to talk about here, way too much to just to throw in a standard agenda. So we've got a couple of slides just staked out for that. So let's talk about our introduction. So application layering has been around with us longer than we'd like to think. It's actually been in GA for around 8 years. And while this technology was ahead of its time, we're seeing massive adoption of it now. And the reason we're seeing this is because, quite simply, we're expecting more of our applications. We expect them to be portable. We expect them to be native. We expect them to function in pretty much any environment that you would ever want to see an application in. So that means physical, virtual, cloud, application publications. And of course, the big side effect of this is we're tired of managing images. No one wants to have to manage 20 or 30 or 40 different images inside of their organization. Ideally, what we'd like to do is cut this down to a single image per operating system. And obviously, that's going to reduce your overall cost and expenses going forward. Now, unlike cloud adoption, which was really a grassroots growth, we're seeing application layering is being utilized by the SMB and the Fortune 500 base with really the Fortune 500 space carrying the bulk of this weight. And the why always kind of interests me. So I ask my customers, hey, why are you doing this? And the biggest reasons we're seeing now are contractors and laptops, and most importantly, physical machines being a liability. So if we want to remove our physical machines from the equation and give you just a link that you log into so you can access your applications, obviously it's a lot faster to provision a machine that way. And I never have to worry about a machine being lost or stolen or destroyed. Now, Citrix and VMware have solutions that function well in their own environments. So when we talk about Citrix app layering, or we talk about anything else that exists out there, these solutions function very well inside of a virtual infrastructure. But the question you need to ask yourself is, why do we limit the best toys, the best technology only for virtualization? Shouldn't it be global? Shouldn't it be across anything that you could possibly imagine, from a physical, virtual, cloud, application publication, or even cloud-based publication methodology? Now, innovation is key in this space, and ultimately these new features are going to make or break how this technology is used in the future. In other words, if we stop innovating, then the technology doesn't really go anywhere. So we need to constantly be making strides towards making the technology better, making it faster, making it easier, and making it work across more platforms. So let's go back in time a little bit and talk about where we started. Now, for the interest of full disclosure, I'm actually very heavily biased when it comes to FlexApp, because I actually wrote the first 3 versions of the FlexApp Alpha way back in 2011. So just in case you're curious, does this guy actually know what he's talking about? Yes, this is one area where I do know what I'm talking about. So the first functions, the first base iterations of FlexApp were very simple. They used a combination of VHD, or virtual hard disk, and symbolic links to function. And the magic moment was when we realized that you could take a block-based device like a VHD, host it anywhere you wanted in your network, and you could mount it just like a local drive. And then if you use symbolic links, which are a built-in function of Windows that they borrowed from Linux, then you could take directories and files and even registry keys and link them directly into your operating system. And this spawned the first version of FlexApp, called UIA, User Installed Applications on Non-Persistent VDI. That was the first thing we ever did. Now, the problem with that was twofold. Number one, the application compatibility was not great. We were stuck in the high 70% for app compatibility. The second problem is that the use case wasn't what our customers were asking for. They said, this is great for developers, but I want something that I can use to control the apps and deploy the apps that all my users are having right now. So we started to evolve things. First, we created GA FlexApp 1.0 that was released in late 2011. It gave us an 80% native application compatibility, so it was up there with the AppVs and the SVSs and the thin apps of the world in terms of app compatibility. We still used VHDs and symbolic links to function, but our compatibility was getting a little bit better. So then we said, you know what? This isn't what our customers want. What our customers do want is something called DIA, departmentally installed applications, where I can take a series of applications, put them in a single or multiple VHDs, mark it as read-only, and then have that linked to thousands of machines at once for instant application updates, instant application mounts, and basically have huge amounts of applications developed and deployed to a machine with no lines and no waiting. And this was a big, big piece for us because this allowed us to get to the one-to-many approach. So we further refined that over the years, and in 2014, FlexApp 1.5 came out, and our application compatibility started getting pretty good. We were starting to get to the high 80s, low 90s in terms of compatibility. And then in 2015, we turned the whole thing on its ear. We said, you know what? Symlinks are no longer the way that we want to proceed. We want to instead use something called a filter driver. Now, a filter driver allows us to go and embed ourselves into the operating system as a transparent part of what the OS does, meaning that with a symbolic link, you can see where the link is. You can see where that process embeds itself into the OS, and compatibility as a result wasn't as good as it should be. But with a filter driver, the OS just links things directly to the system, and the app has no idea that it's there. It just functions, it just works. And once we did that, our compatibility rate shot up to over 96%. And this is what we call modern FlexApp, and that brings us to where we are today. So let's talk about what we can currently do with FlexApp application layering, and most importantly, the features that our customers seem to be coming back with the most. So first, we offer full functionality on physical, virtual, and cloud platforms. Now, when it comes to the virtual and cloud platforms, that means any hypervisor that's currently in GA today. So I know a lot of you guys are standardized on Zen and Zen hypervisor. You're constantly frustrated that things are not supported by it. Well, we are. This also means every single other GA hypervisor platform is fully supported, and all the cloud-based platforms that are also in GA, those are fully supported. Now, we also allow for application publication, of course, on XenApp, WVD, AppStream, RDSH, and we also offer a newer feature called DLL micro isolation. We're going to be demoing this a little bit later. It's a really cool function. It basically says, if I have two apps and two VHDs, and they are both trying to inject a DLL in the system, it's the same DLL, but a different version. Normally that's going to cause one of the two apps to crash. But what if we create a space that allows us to swap in and out that DLL based on application activity? Well, now both apps can live side by side, and we don't have to worry about DLL compatibilities going and breaking things. Now that micro isolation feature we also offer with the registry for the same reasons. If I have two applications that are fighting over the same registry space, I want to make sure that they can both survive regardless of what the environment is doing. As I mentioned before, our application compatibility rate is at 96%, 96.7 if you want to be really specific about it. We also offer compatibility with device drivers, system services, COM plus and DCOM. And then finally, we're also offering a block cache for VHDs in the target system. This seems weird. Why would you want that? And the answer here is redundancy. If I am caching the blocks that an application needs to function and making it portable at the same time, what happens if your storage goes offline? Well, the short answer is you lose all your apps. But if you're caching all those blocks and your storage goes out for 15 minutes or an hour or 4 hours, your users still function. Nothing breaks, everything continues to work. We also have a full filter and logic engine, meaning that we have huge amounts of combinations that you can say, under what conditions should I be able to deliver these applications based on where thin client is, or is the first letter of the user's last name B, or is it Tuesday, or are they in a certain security group? We can use these logic entities or this filter logic engine to say, when should I define when a user gets an application? Our biggest claim to fame is this: our packages are forward OS compatible, meaning that if you take an application and you capture it in Windows 7, for example, you can play it back on Windows 8.0, Windows 8.1, Windows 10, any version of it. And then also you can play it back on Server 2012, 2016, and 2019, all with one package. So this means that one package works across newer operating systems, but unfortunately you can't go backwards. So it usually makes sense to start with whatever oldest operating system you have to worry about. Now, we also have multiple deployment methods, which means that this isn't just about delivering applications on boot. I can deliver them on boot. I can deliver them on profile load when you log into a system, or I can also do something called click to layer. Click to layer is useful if you're trying to keep your consumption down as low as possible. So in other words, applications that are installed in a system, especially if they have running agents, consume a lot of resources. They consume memory and CPU and things like that. And if we're in a place where we're charged for those things, either through a chargeback model or through the cloud-based processes that everyone seems to be using, we want to try to keep the machine utilization as low as possible. So what happens is we don't load those applications until the user clicks on the icon. Now, in terms of performance, machine boot is the fastest in terms of delivering the application to the user. Profile load is the second fastest, and click to layer is the slowest, but all those are still going to be really, really quick, as we're going to see in the demos a little bit later. So what we want to talk about next is first our standard architecture, and this is where ProU and FlexApp profile management essentially come together. This all starts off with the big blue box in the top left-hand corner of the screen called the Profile Unity console. The console has two jobs in life. Number one is to give you all the executables and code and configuration files to run Profile Unity and FlexApp, and the second is to perform licensing duties. Now, what we do with all that code is we normally propagate it to the netlogon share of your primary domain controller. We do this because if you have 20 domain controllers and 19 of those go down, ProU and FlexApp continue to run. If the ProU console goes down on top of those 19 DCs going down, again, we still run. We like to leverage replicated and fault-tolerant storage, so if you have a massive storage outage in the midst of all those DCs and consoles going down, again, we still run. Now, part of that doesn't make any sense. If I said that the console is responsible for licensing functions, why is it things still happen or run even if that goes down? And the short answer is we never stop you from running, ever. Even if the console goes down, even if I can't talk to a licensed server, even if your license is expired, your users will always run. And this leads to our very robust DR methodology. Now, once we have all that code out there on your netlogon shares, which is usually a payload of around 100 megabytes, we next assign a GPO that says these users and these machines are going to run ProU and FlexApp. And we push that down to the systems. The systems then talk to the netlogon share. They run and cache our agent. They pick up the configuration file, and then they start pulling in applications and profiles. Now, the way that we handle profiles is pretty unique. We use a combination of 3 different modes to make all this stuff happen. We first have an engine called portability, which is CRC'd and corruption detection checked and hashing checked to make sure that your profile always stays corruption free and can move between different versions of Windows, anything Microsoft has built in the last 17 years. We also use folder redirection with synchronization, so you can migrate your user data to where it needs to be or make sure it's backed up or redundant. And then we also use VHDs to cache the profile to make things nice and fast when you first log in. Now, FlexApp also uses VHDs and also uses the Profile Unity configuration to run. And what it's doing is it's taking all these VHDs that contain your applications, it links them or mounts them for as many users as we want, and then it plays everything back through our filter driver. We can do a lot of other very clever things with VHDs. So if you want to just cache your OSTs and PSTs and make those portable, or if you have an application that requires block level storage on the C drive or things like that, VHDs help us solve a lot of these really complex problems very, very easily. Now, the second architecture we have is the cloud-based architecture, and this comes at the response of our customers asking, can I do this without managing my own storage? And of course, whenever that question comes up, the big object-based storage platforms that we see are Amazon S3, Google Buckets, and Azure Blob Storage. And the short answer to your question is yes, you can manage this without having on-prem storage. In fact, if you're using this as a DR play, or if you're using this as a global play, this is an extremely attractive option, because what we can store inside of this object-based storage is A, FlexApps, B, the Profile Unity and FlexApp config, C, the Profile Unity and FlexApp files, and D, we can also store your portability or the backed up compartmentalized portions of your profile that allow you to load a profile in any version of Windows that you want. The problem with this methodology is object-based storage is not like a drive letter or a UNC path. You just can't randomly read or write things to it. You have to be very explicit in how you call it. So in order to meet the need of user data, which is normally redirected folders like your desktop, your documents, your music, your pictures, your videos, we also operate with what we call document repository services. That means Amazon Workbox, Dropbox Business, Google Drive, OneDrive. And the biggest problem my customers always have when working with these platforms is how do you get your data in there? So of course, the same synchronization engine that allows us to redirect folders also allows us to migrate data into these platforms for you instantaneously. And that's what happens with the whole architecture piece. Now, you might be wondering, why do I keep talking about profiles if this is about application layering? I mean, this is really about making applications portable. So why does the profile matter? Well, the long and short of it is that if applications are to be treated as portable, then the data needs to be as well. And this is because you can't use an application without user data, without your documents or without your registry keys, without your settings. An application is essentially useless. So profile-specific data should not be part of applications. This is especially true if we wanted to work across multiple OSs. They need to be two separate entities. You have your core application and you have your core profile. Essentially, we want everything to be modular. So I can rip the OS out of the equation, replace it with another one, and your profile should just work, and your applications should just work. Now, application layering works in both persistent and non-persistent environments. This isn't just something that's relegated towards PVS. You can use this with MCS, you can use this with cloud, you can really use this anywhere. But most importantly, profile data should be consistent across OSs. Just because you upgraded from Server 2016 to Server 2019 or Windows 10 1607 to 1903 doesn't mean your profile data should be thrown away. It should come along for the ride. And most importantly, large data sets like Outlook and OneDrive caches should also be portable. So if you recall earlier, I said you can keep those inside of VHDs and have them follow you around, while at the same time having that concept of portability of your profile, creating a hardened, redundant, fault-tolerant version of your profile so everything works all the time. And again, just to reiterate this, applications are useless without user data. And the other opposite is true as well. User data is useless without applications. Without ability to run what your data is, all this stuff is redundant. So now we're going to get into the fun stuff. We're actually going to go through the first of our 3 demos. And the first one we have is a physical and virtual deployment demo. So we're going to go log into a non-persistent Windows 10 session. I'm going to load in about 110 unique applications via FlexApp, and I'm going to supplement that with a 22 gigabyte profile that has lots and lots of junk in it. And we're going to see how all this stuff works together, and most importantly, what is the user experience throughout the entire process. So I'm going to go and log into my system, and just in case you're curious, I'm doing this in Hyper-V. Please don't yell at me. And I'm going to have Profile Unity and FlexApp fire itself up on the desktop, and it's doing that right now. And it just made available my 110 applications, and it provisioned my 22 gigabyte profile. So you can see I've got a lot of customization here. I've got my customized icons on my desktop. I've got my desktop background. And if I start digging into my profile, you can see that I'm a hoarder of data. I just hoard lots and lots of junk. So you can see stuff that's been pulled in from about the last 10 years from places like my desktop, my documents, and essentially these profile elements now float around with me. But this is not as important as the registry, because the registry is a very volatile space. We all know that profiles can get corrupted very easily. So it's very important for me to have a corruption-free registry experience. And this registry has been with me for about 10 years now through my tenure at Liquidware and seen 7 different versions of Windows. So how do we do that? How do we make all these things corruption-free? Well, first, I need to speed things up. So in other words, if I want a fast login like what I just got, I need a cache space. And my cache space is mounted as a VHD in my C users directory. So I get ultra fast logins in my non-persistent systems. And that's exactly what we're doing here. We're just mounting a VHD and linking it to C users MAT. So this is essentially my cache. But again, I need a hardened profile. And the way that we do that is we compartmentalize the registry and the file system into these series of files that have first corruption detection, Second, CRC and compression to keep them super compact. Third, they have hashing, and you can see I'm bringing up on my screen right now an example of one of my hash files for my HKey current user software section of the registry. And then we also have different sections of areas that can only work with certain versions of Windows, such as Windows 10, which has a separate area for example, active setup of the Windows themes. But because we're using such heavy compression, this also means I can back stuff up. All right, so now let's talk about applications. These are some of the applications that I'm going to be working with today. A lot of these are big and heavy and complex. A lot of them have things that I mentioned before, system services, device drivers, COM+, DCOM objects, and I'm just going to load this system up. We're just going to fire off tons and tons of apps. So I've done 7-zip and Java config and FileZilla and Evernote and FooBar 2000. I'm doing GOM Player right now that's complaining I don't have a sound card. And we'll do some Google Chrome and we'll let that load up. And then we're going to go and fire this up with a bunch of other stuff. We'll do some Greenshot, which is loaded, and I'll do some image burn, which has a device driver loaded into it. And every single app on this system has been FlexApp, so you can very clearly see our compatibility. And now what I'm going to do is I'm going to create a DLL conflict. So I'm going to open up both OpenOffice and LibreOffice at the same time. These two apps both fight over a DLL. So what I'm going to do is load them both up, and you can see they're both loaded. So how did we make this magic trick occur? Well, our filter driver is essentially swapping in the DLLs as the programs require them. So even though I have two different DLLs, that virtual file system service, this one that I'm trying to highlight right now, you can see it uses a tiny, tiny bit of CPU every time it needs to swap a DLL from one program to the other. That's what we call micro isolation of DLLs. And I'm also using about 136 megs of RAM. That's the virtual registry kicking in. And that's very important because that means when I leave this OS, if it's not non-persistent, everything comes out nice and clean. No traces of reg keys or files or anything is left behind. So I'm going to fire up a whole bunch more apps. So I'm just clicking away, as you can see here. There's some VLC. We've got some WinDirStat, one of my absolute favorites. And I just fired up some Terracopy, which replaces the Explorer shell handler, and some WinSCP. And let's click on some WinRAR. So I really, really loaded this system up with about 30 applications. And what did we notice here? The performance was outstanding. So remember, we're caching on 3 different levels in order to make this work. We're caching at the storage controller level. We're caching at the Windows level because Windows caches VHDs when you go and mount them. You can see part of my caches in there right now. And I've only got 4 gigs of RAM, but this thing is absolutely screaming along. And of course, the third cache point is the block level caching that I mentioned earlier. So we're also making sure that if there is a problem with your storage, nothing's going to go and break. All right, so the last thing we're going to do is we're going to have a lot of fun here. I'm going to rip all these applications out of the system, and I'm going to replace them with cloud-based apps. And we're going to demo the whole thing again to show you what happens when I take my apps away. So I'm going to log into the ProU console, which I'm doing right now. We are AD aware, so I'm going to use my AD ID. So this is me logging into AD. And we're going to wait for that to come up. And the first thing we're going to take a look at is filters, because filters are the underpinning of how we achieve our granularity. And these are very, very flexible. So the first filter I'm going to look at is a basic filter that says, all right, what are my options? So I have and/or aggregates. I have all these different condition types against thin clients and files and OUs and AD objects and system objects. I have lots of pattern matching. I have automatic AD integration. I have machine class, OS type, connection type, and system events. I can really do a lot of very cool things with filters to decide under what conditions should you get a setting, like a registry key or a shortcut, or in most cases, what should I do when I get an application, or how should I get that application? What users in what organizational unit security group, and all those other variables can use it. So this is now my configuration. We're going to go play around with it a little bit. These are all the things that I did in order to make my applications and my profiles portable. Now, the good news is 99% of this was out of the box. I didn't have to do anything or know anything to make this profile portable. So all those cool things that I just showed you, all I did was run through a guided wizard and it did all the work for me. So now what we're going to do is I'm going to go into my applications, and this is my collection of 110 apps. We're going to rip that apart. I'm going to start pulling in cloud apps, specifically cloud apps that I have stored on Amazon's S3 in Virginia, and it's roughly about 700 miles away from where I am right now. So this is going to be really interesting. If you notice, I also by default have cache blocks locally turned on, which means that, again, if there's an S3 storage outage, which almost never happens, I still get to keep my apps. So I'm going to deploy this configuration to my netlog on share, and that's where it's going right now. And that's it. So now I just ripped and replaced all my apps, and let's go see what happens when I destroy this virtual machine, log into a new non-persistent session with the same profile, but with cloud-based applications. And we're gonna go do that right now. So in the background, I'm just destroying my VM, and we're waiting for that to happen, and it's destroyed, and I'm going to restore my snapshot, and there we go. We're back to ground zero again. So now we're going to see what happens when I log back into that brand new fresh system that's never seen me before with cloud-based apps, but the same profile. So profile Unity still takes the same amount of time that it took to load, and just in case you didn't have a stopwatch out, that was a 10.9 second login. You can still, I've still got my desktop background, my icons, everything that I had before in my profile is now the same, but wait, where are all my apps? Well, they haven't been delivered yet. So right now they're actually being pulled down from Amazon S3. And in a few seconds, you're gonna see them populate on my desktop. So you can see FileZilla's right there. That's one of the apps that I selected. And you're gonna see a few others. You're gonna see Google Chrome. You're gonna see some Foxit Reader. You're gonna see a few others. And as they populate, the ones that I have in common with my shortcuts are in my shortcut location. But the reality is that's just my little shortcut collection. What matters mostly is that the start menu still functions, and it still does. All my apps are in there, and all the icons that I have populated to my desktop that I've specified are there as well. So there's my apps. So let's go fire up some FileZilla first, and let's see how long this takes to run. Well, that was pretty quick, wasn't it? Well, let's fire up some other stuff. Let's fire up some Foxit Reader and see how Foxit Reader does when I'm essentially making this application work across the open internet. And there, Foxit Reader went pretty well too. So we're going to leave that open, and then we're going to try some harder stuff. All right, so we'll do some CutePDF. And there's CutePDF. That's pretty small, so it went pretty quick. And now we're going to do a big boy. We're going to do Google Chrome. Now, while I do Chrome, I'm going to open up Task Manager, and I'm going to go and take a look at what my Ethernet is doing, what my NIC is doing for bandwidth. So you can see I'm spiking out at about 100 megabits because it's not only loading Chrome, it's also loading Chrome's homepage at the same time. So Chrome's now loaded, and my page is now loaded, but remember, I'm using caching here. So if I go and kill this copy of Chrome and then reopen it, I should expect that my bandwidth is going to be drastically reduced, and all I'm pulling in is what's necessary for my homepage to load. You can see that the Ethernet barely even registered anything on that. So that's what happens when I just rip all my applications out and replace them all with cloud apps. The caching mechanism is going to say, all right, any block that I pull over, yeah, it might take a few milliseconds to get to me, about 20 or 30, but once it's there, the applications are still going to run at full speed. And any subsequent close and reopen that I do is going to be lightning fast. In fact, you're going to be finding that this is at or faster than native execution because of all the multitudes of caching that we employ. All right, so that's demo number 2, where we ripped and replaced our applications. Now, the real magic question is, how did I get here? How did I actually get these applications to capture where I can just drag and drop them wherever I want at any system at any point in time? So that's what we're going to cover right now, application capture and upgrade. So we're going to do all this as one step, which would drive pretty much any other product nuts, but we're going to make sure that we do an installation and an upgrade at the same time. And the upgrade that I've chosen is really difficult. I'm going to do FileZilla, which you're going to say, yeah, FileZilla is easy. Why are you choosing that one? Well, FileZilla has one of the worst rip and replace upgrades I've ever seen. So if we can do this, we can really do everything. So the first thing we're going to do is fire up my console, and I'm going to go grab a package. I'm going to grab an old version of FileZilla and paste it on my desktop. I'm going to log into my console, which is essentially installed at a clean version of Windows. I'm going to use my AD ID to log in, and I'm going to go and take a look at where all this stuff is going to be stored. So I'm going to go and take a look and see what happens in the background on my network when I make a VHD using the FlexApp process. Now, the most important thing to note here is that we are a thread-based capture mechanism. We're not differential-based, which means only what the app needs is captured. So I'm going to specify the name, the location, any switches I have, where it needs to live in the network, and my size should be 3 times of whatever the package is going to need to survive. So if FileZilla is going to be a gig, I'm going to make this 3 gigs. Compression's not your friend because it uses local compute CPU, so I'm going to skip that. And expandable disk type is good because I want to keep the space on my network as low as possible. So I just click next. And you can see that I've got my little package right there. So there's my little FileZilla copy, and there's my VHD inside of it. It's been journaled and formatted and indexed, and we're watching 2 threads. We're watching the thread of the installer, and we're watching the thread of the user portion of Windows Explorer EXE. We do that because if you create a shortcut, register a DLL, modify some registry data, I want that to be captured. But if you're, for example, a Windows process that's a background task, I don't want that to be captured. So you can see all this stuff as far as Windows is concerned is native. It all looks native. It all looks normal because as far as it's concerned through our filter driver, it is. So FileZilla is now installed and captured. Now we're going to go upgrade it. And again, this is a terrible upgrade because it's a rip and replace. It's going to uninstall the old version. It's now going to reinstall a new version that it just downloaded. And there we are. FileZilla has now been completely upgraded to the latest version as part of one capture. Now, what did you notice about this? You didn't need to be an engineer to do this, did you? No, any admin can do this. So in other words, if you can run software installations, if you can install a package, you can run FlexApp, and there's no limitation to this. So in other words, if you wanted to do 10 captures as part of one VHD for an entire department, that's fully supported. If you want to do 10 applications and 10 separate VHDs, that's fine too. We're not playing any favorites here. Now, if we go back into this when I'm finished, the application comes out clean. So remember, we don't leave any junk behind, no reg data, no file data, no stuff like that. So I'm going to choose an icon, and that's going to embed that icon into my package. And now I can go and publish the package. The package is now done. And thanks to our thread-based capture, as opposed to a differential-based capture, my package is super tight. It's not a very large package. The OS overhead or the VHD overhead is about 23 megs, and you can see my package isn't much bigger than that. So what did we capture? What's inside of this package? Obviously, I have a lot of options here on extending, adding new installations, cloning, adding scripts. I can go and specify whether or not a package is dependent on another. But what's inside of it? What did we actually capture? And again, our thread-based capture process means everything stays clean. So inside of my file system, for example, there's nothing in here other than what FileZilla needs to function. So all the running processes, the underpinnings of Windows were not captured. Same thing with program data, because this is where all my shortcuts live. And the same thing is going to happen if I dive into the registry. Only what the application needs to function is going to be here. And you can see that there's some stuff for the toolbar, because FileZilla does that. And there's my shell browser and some other cool things in there. But again, this is why we're able to do forward compatibility so easy, is because when you're only capturing what the application needs to survive, this means if you push it into newer versions of Windows, you can very easily make your apps work across all different kinds of platforms. All right, so let's talk about the elephant in the room. Let's talk about what can't you do with FlexApp. And there's three things that you can't do inside of FlexApp. Number one is anything that starts before your OS does, like a pre-boot kernel. Obviously, we depend on the kernel to function, so you can't do stuff like that. Number two is anything that modifies the OS kernel. So if you have an application that changes the way the Windows kernel works, that's going to be out of our wheelhouse again, because the kernel has to load before we do. And then last but certainly not least is we're not going to make applications that aren't designed to function or incompatible with your version of Windows magically work, because in this particular case, what this means is we're bare metal. We're working the same way that an application normally works if it were natively installed in the system. So we're not magically making things more compatible, unless you have a DLL micro isolation issue or a registry app micro isolation issue. We will fix those. So what I've been doing is just playing around with some of the other options that you can see on the screen here, and we're just going to close that out just to make sure that everything's nice and clean. As soon as my package was removed, you can see there's no traces of it left behind, and now I can go and continue on and make other packages if I want to. And again, you can do this any way you want. If you want to have, for example, a targeted departmental methodology where I go after human resources first, and HR has 12 apps that everybody needs to function, 10 are used by everybody and 2 are only used by 1 or 2 people. There's nothing wrong with that. You can put 10 applications into a single VHD, capture them all in one shot if you want to, and then you can use filtering to decide who that goes to. And you can say, all right, I'm going to capture another VHD with a single app for that one user who needs it, and then another VHD for the other user who needs that single app. Now with 3 captures, you've just taken care of an entire department. And if you go down through your departments, this is how we foresee you doing application management. Obviously, it's really easy to upgrade these things. It's easy to add new installations into them. You can remove them, you can swap them out instantly, and the users get their apps instantly. Again, through the boot process, through the user login process, or through that click to layer methodology that I mentioned a little bit earlier. All right, so I know we're operating a mile a minute here, but if you guys are still paying attention, the last thing I want to cover is our future state. So first thing I'm going to cover is our near-term roadmap. So you're going to expect to see this stuff by, let's call it Q1, maybe the beginning of Q2 as of 2020. first thing we're developing, built-in packager OS rollback. And what that means is whenever we capture apps in a packager, just like when I captured files a moment ago, we want to start with a clean image. Why is that? We're making sure that the image is clean after we capture our packages. There's no junk left behind. Why do we have to make sure that that's clean? Well, the issue is we're not capturing profile data during an application capture. We want that data left behind. And that means that is the only junk that is going to be left behind in a packager. So having snapshots and rollbacks is important if we want a super sterile environment where we capture the most stable packages. So we're going to do all that for you now so you don't even have to mess with snapshots. Second thing we're doing is auto install runtimes. It's very, very important to have your prerequisites installed in your base image and your packager to make sure everything goes smoothly. So your C++ libraries, your C# libraries, your .NET runtimes, things like that should go in the base image. Now, instead of having to go and hunt all those down, we're going to do all that for you. Next, auto OS optimizations. Again, it makes sense to turn off things like Windows Defender and Firewall when you're capturing applications. So we're going to do all that for you as well to make sure that the whole process is smooth and seamless. Next up is version control. Right now we have rudimentary version control where you generally put the versions in your package names. That's not good enough. We're going to do that for you as well. So you have automatic version control built into the UI so you understand exactly which package was built before another package. And that makes it easier for not only change management, but also deployment of applications. Failed FlexApp's posting to event viewer. So in other words, if there's a reason a package did not capture, again, we have a 96.7% compatibility rate. Every once in a while, you might run into an issue. It is really a lot easier to be able to diagnose things if you can see it straight in event viewer as to why it went sideways on you, and then be able to remediate that and capture it correctly. Next up, we're merging layers. That allows us to create two separate VHDs. So remember in our HR example earlier, we said we have those two users with one app apiece. Well, suddenly decided somebody in marketing or whatever, somebody decided to purchase more licenses, and now I want those two VHDs, those two packages to become one. Well, merge layers allows us to do that. So I can take two VHDs and make them a single VHD and deploy two apps as a single entity. Next up, we're also adding post-login support. Post-login support basically says, after an application has been deployed, can I do something else with it, like fire off some scripts? Or do I have the ability to fire off an application after a user login? So if I'm trying to make the user login as fast as I can possibly make it, and it's okay if an application is available 2 or 3 seconds after a user is logged into a system, that's what post-login support does for us. The other thing we're adding is something called a pre-cache block map. Now, this is really cool. Before we said that if you turn on the caching function of FlexApp and your storage goes offline, what happens? Well, you keep your apps if the cache is turned on. The problem with that is you have to get the blocks first. In other words, you have to run the app and get the block in order to cache it. So if you haven't run the application before and your storage goes down, well, you don't have the blocks to run the application yet. But what if we could map that out? What if we could say, all right, these are all the blocks that every app inside of this VHD needs to function. Why don't I just pre-cache that for you? So even if you've never run the app before and your storage goes down, you can still run the app. And that's what pre-cache blocking does for us. Next up is trigger support. Now, triggers require a little bit of explanation. We have this thing built into Profile Unity called trigger points. Trigger points react on what a user does. So I can say, for example, if a user opens this application up, I want you to inject this registry code. Or every 6 hours, I want you to back up the user's profile because they never log off the system. Or if a user changes thin clients, I want you to pick up where that thin client is and map the printers that are closest to that thin client in their VDI session or in their Zen app session. That's what triggers do for us. So what we're doing is we're expanding triggers so that they also apply to FlexApp. So that means when I launch a FlexApp, I can basically do anything I want on top of that for the ultimate in granularity and control. And the last thing we're adding is something called the FlexApp Packager API. And now this is going to be in beta for the next release, but we're going to be expanding that in the future. The idea here is I've already shown you how it's remarkably easy to be anybody, not an engineer, just a regular old user, or just call it just somebody who just does installation packages. It's really easy to just go and install things. You don't have to have a degree in computer science to do it. So if it's that easy, why can't it be automated? In other words, why can't we say, this is my entire package library, just go do it. Write a script that goes and packages these things for me. Well, that's exactly what the packager API is designed to do, to give you an interface or an API, if you will, to go and automate all these captures so you don't have to pay somebody to do it. Now we're going to talk about the real fun stuff, where we're going long term. So expect this is going to be sometime around 2020, maybe a little further out, but more than likely a little sooner than that because our dev team moves super fast. First thing is we're going to be adding micro isolation visualization in the packager. Now this one requires a little explanation as well. So you remember before I said we had that micro isolation piece that allows DLLs to be swapped and shared through our filter driver, and we do the same thing with the registry. Well, the problem is you can't really see that very well. We have an API where you can go and take a look at it after it's been deployed. But what if you're packaging all this stuff and you want to see how applications conflict before they're deployed? Well, that's exactly what this does. I can read captured files, originally VHDs. I can play them back in memory. I can show you where those collisions are going to occur. So where are two applications going to step over each other on the same registry space, or where two apps are going to fight over two different versions of the same DLL? And the reason you want to know that is because ultimately when we swap things out, it might require a little bit of resources, a little bit of CPU to swap things out, or a little bit of memory to make the registry swap out. And if you know where those bodies are buried, it's going to be easy to keep your IO and your CPU and everything else down as low as you possibly can. So this, again, is a really important feature for us. Next up, we're going to be expanding the API to be full API documentation and automation, which means it's no longer going to be in beta. You will have automation components that do all the capture options for you. So again, you don't have to pay anybody to do your captures. You can let the automation handle most of it, and then anything that's giving you some trouble, or maybe the installer's a little wonky because you have to copy some stuff from A to B, you can still do that manually. But again, if we're getting rid of 90% of the work that goes into converting packages into FlexApps, that's a huge win for everybody. And that, of course, means automated package creation, which is the next feature that we're adding into it. Now, we're going to talk about two really, really cool functions that I'm extremely excited about. I mean, obviously, everyone has heard about what Microsoft's been doing with the future of AppV. AppV is getting rolled into MSIX. So essentially, they're going to be one entity now, which means if you're used to packaging things in AppV, that's great. You can still do it. If you want to use the new MSIX format, again, you can do that too. The problem is your traditional downsides to AppV and MSIX, they don't go away with any of these new versions. So things are a little slow. They're not exactly the best in terms of compatibility. Obviously, you need to be an engineer to capture these things. So we stepped in and we said, what happens when you go and combine an AppV package or an MSIX package with FlexApp? Because as we all know, MSIXs are a little bit weird. They actually go and copy data into your profile, and that copy routine takes a lot of time. We don't have to do that. FlexApp just links things in places using the filter driver. So what if we stuck the two together? And there's actually some really cool videos that our company founder has done on exactly this process. You can go and Google it, you'll find it. And what it means is that we actually speed up the execution of AppVs and MSIXs by quite a bit. So when you combine application virtualization, AppV and MSIX, with application layering, you get the best of both worlds. You get the speed that you want, but you also get the ability to go and say, if I don't want one app to talk to another app, or if this app is broken in my version of Windows, you can now save yourself from those headaches and trudge along those old apps that have been with you for 20 and 30 years and make them work in modern versions of Windows 10, but not suffer the speed penalty or the performance penalty. Really, really cool way of doing things. The last feature we're going to be adding is application cloaking. And this is great for RDS, XenApp, or your base image. The idea is that, you know what, some apps just belong in the base image, and occasionally you're going to run into an application that just won't layer. You've got to put it in the base. But I don't want to have to manage 2 or 3 or 4 or 10 base images. So is there a way for me to maintain licensing and still have a single gold image at the same time? And the answer is yes, you can do that through application cloaking. So you can say, all right, I'm Mr. User, and I log into a system, and I don't have access to Visio, but Visio is installed in the base image. Cloaking will hide Visio from you to make sure you're still in license and compliance, or any other application that you come up with. So make sure that I can have one gold image, I can maintain license and compliance, I can do app virtualization, I can do application layering, and I can still hide or show applications depending on who you are. And if you combine this with that filter engine that I showed you a little bit earlier, it really makes the whole process remarkably easy. So, ladies and gentlemen, I know I've endlessly pontificated here on all kinds of cool stuff, and we've been going a million miles an hour, but I certainly wanted to thank you so much for your time. And now we're going to turn everything back over to our handlers. So, the floor is yours.
All right, so Bart, I think we saw a lot of questions come in. So I think we have a few minutes. We can go through those.
Yeah, it started slow, but it really took off at the end. First question is, what type of applications are not suitable as a FlexApp? For example, CAT applications or something in that nature.
Oh, that's a good one. So I briefly covered the three things that FlexApp won't do. I said you can't do anything that starts before Windows does, so a pre-boot kernel like disk encryption. You can't do anything that's not compatible with your version of Windows, and you can't do anything that, of course, goes and modifies the OS kernel. So that's what you can't do. But there are also a set of applications that you shouldn't do. So just because you can do something in FlexApp doesn't mean you should. So I've had clients come to me and say, hey, Matt, I FlexApped my antivirus, or I FlexApped host intrusion prevention suite, I FlexApped SEP or McAfee and all these other cool things. And that's great. But again, those things should be in your base image. You don't want the security of your organization hinging upon an application layering solution. And it's not because it doesn't work. It's because it brings the opportunity for fat fingers. So I showed you that really cool interface called filtering. We can decide who gets an application and how they get it. What if somebody makes a mistake there? What if somebody accidentally turns it off or deletes it or removes the package? Well, now the organization has no AV or no HIPs. So again, security software should go in the base image. Apps that are utilized by 80% or more of your user base that are site licensed should go in the image. Anything else, that's what FlexApp's for. Excellent question, by the way.
Okay, so another question on caching this time. So caching, is it for one user or for all users on the machine? So if one user starts the application, it caches. Can a cache be used for the next user that starts the same application, or how does that work?
I love it when my my clients are paying attention. Yeah, that's a great question. So the short answer is yes, and that's actually one of the biggest advantages that we bring forward is that if I do this on XenApp and when I have or an RDS or a shared environment where I have one machine hosting a lot of users but only 20 or 30 applications, caching needs to be ubiquitous. Caching has to apply to everybody because the first user that launches it, say they do it from an app that's stored in S3. First user that launches that app, that launch is going to be slow. We have to wait for all the blocks to come over from S3 to our local machine and cache it. Now, if everybody shares the cache, that means future executions are going to be lightning quick. But if we don't share the cache, that means everybody has to put up with that first launch performance hit. So the way we designed it is cache is universally shared at the block level. So if one user launches at once, yeah, their first execution is going to be slow, but for everybody that uses that machine, as long as the cache is there, it's going to be lightning quick.
Sounds great. So how does this differ from the Citrix required Unidisk app layering solution? You should have seen that one coming.
That's a loaded question if I ever heard one. So the two are fundamentally similar and fundamentally different. Okay, and one of the other questions that I've heard is, do you guys compete with the Citrix app layering? And the short answer is no, because Citrix app layering has a very, very specific use case, which is to make applications work inside of your Citrix environment, and that's it. We're saying, why does it have to be just that? Why can't it be physical? Why can't it be cloud and things like that? So what makes this different is first our differential capture. Unidesk uses a differential capture. We use a thread-based capture. So that's difference number one. Difference number two is we have our filtering engine, so we can decide on how things get leveraged to the system. In other words, what users under what conditions are going to get these applications. And then big difference number three is, of course, the caching mechanism. What the two solutions do have in common is the storage mechanism. So we both use VHDs, and the deployment mechanism. We both use filter drivers. Everything else is very, very different. And here's one thing I want you to remember. Why should you just choose one? Why can't you have both? Why can't you run them side by side? If you're familiar and comfortable with doing things in Unidesk, there's no reason to change that. You can supplement things with FlexApp. But you can't use Citrix app layering in physical, so what work you do there ultimately benefits your whole company as opposed to just VDI or just XenApp or just Zen Desktop. This is essentially an ubiquitous way of deploying things.
Okay, so we got a few more. Mike asks if I've heard of the app layering tax on the OS versus a traditional SE installation. Does this tax exist? And if so, what can we expect from that?
That's absolutely 100% true. There is no such thing as a free lunch, ever. Doesn't matter what you do. So let's talk about what kind of tax or what kind of load will be placed on the system. So first, there's a VHD penalty. Whenever you load a VHD, you have to wait for the VHD to load to do anything. Now, if you use a Windows VHD load, in other words, if you load things through computer management or disk manager or things like that, VHD loads normally take around 2,500 milliseconds. We have our own VHD loader, cuts it down to about 250 milliseconds. So you can basically, you'd think that that would be additive. So if I have 10 VHDs, I'd be waiting for 2.5 seconds. And no, we're actually loading those in parallel. So it's a lot lower than you'd think in terms of login execution. So that's the first penalty. Second penalty is the overhead from our file system. Now, we're using a filter driver, but if you remember, when I was really beating that system up and we started doing things like the DLL micro isolation option where I was doing two conflicting apps fighting over the same DLL, what was the overhead of my VertFS service? And the answer was not a whole lot. I was seeing a maximum of 1 to 2% of my CPU being used only when I had a DLL conflict. Under any other circumstances, it was sub 1%. It was actually just hanging around there at 0. And with about 110 unique applications, my memory overhead for layering was about 136 megs. Now, the reason that that overhead exists is because that's where our virtual registry space plays in. So in other words, we earmark memory for the virtual registry for these applications to get injected in. Now, why that's so important is, let's say we just injected it raw, straight into the registry and didn't change anything. Well, that's great until I have an application that's incompatible with another app, and then I can't get that data out of there. Or if I have an app that doesn't like the registry keys that I have and it starts behaving badly, again, I can't get that data out of there. So that overhead is necessary not only to make things faster, because memory is always faster than disk, but to make sure that apps don't fight with each other and an app that I uninstalled in the past doesn't impact compatibility with an app that I install in the future. So the long and the short of it is, 250 milliseconds is the VHD load penalty. With 110 apps that I had, you had about 140 megs of RAM. That was the IO penalty, memory overhead penalty. And then nominally about 1 to 2% of a CPU on my system. And again, I'm not using enterprise grade hardware. I did all this stuff in my lab. In my lab, I'm running a quad core Ryzen with 4 gigs of RAM as the VM. So it's not a screamer in terms of most natures of things, but it is a fairly decent system because I feel it's representative of what most of my employees, what most of my companies are deploying today.
Okay, perfect. And a small question to wrap up, I think. If you're setting up a POC, the management and packages servers, do they need to be joined to the domain or can they just be standalone?
Oh, that's a good one. All right, I'm going to answer that first, and I'm going to give you a shortcut because my logic is, why should you even have to stand anything up? So the first answer is no, they do not have to be joined to the domain. In fact, we recommend that they're not joined to the domain because when you join a system to the domain like a packager, even if you block all inheritance in GPO, you're still going to get your default domain policy. And I don't know what that policy is. I mean, you could be forcing antivirus, you could be forcing stuff to run, and I don't want that to gum up the works when it comes to a packager. But in terms of these captures, why should you have to capture anything at all to try this out? So if you remember, when I was going through my demo and I ripped out all my applications that were locally installed through FlexApp on my local LAN and I replaced them with all those S3 packages, guess what? That's all out of the box. So if you do a POC with ProU and FlexApp and you just deploy the ProU console, even if you do it in Amazon, because we have an Amazon machine instance that lets you do it too, what happens is that all those packages that I was attaching and demoing, you get access to those. So in other words, you stand up a POC, you stand up a ProU console, you deploy it into your NetLog on Share, you deploy a GPO, and then you just drag and drop the stuff from S3, and you can test out FlexApp without capturing a single thing and see not only how it's going to work in your environment, but how it's going to work in your environment with packages that are stored in Virginia. And if you try it out, I think you'll be monumentally impressed.
Okay, so one last question, I think. Does it work with the very much hyped MSIX app attach that is planned for Microsoft?
At this time, that functionality is in beta. And again, as I mentioned, you can go on YouTube and see some of the cool stuff that our company founder has done with it. His name's David Benneman, really brilliant guy if you've never met him before. However, it's not currently in GA. We expect it's going to be GA in Q1 of 2020.
Okay, so I think that's all for questions.
Outstanding. Thank you so much, Bart. I appreciate that. And thank you everyone else for all the awesome questions. This was a lot of fun. And now I'm going to turn everything back over to Stephanie. Stephanie, this is all you.
Awesome. Thank you. Thanks, Matt. Let me grab the screen really quickly. Just have a couple of closing slides for you guys. First of all, I put a few links in the chat window for you. There's some resources from Liquidware for you to check out, and I think a link to try some things out. There's also a handout for you can download and take a look at. So yeah, take a look at all those things. In the chat window, I also put a link to our CUGC events calendar. You'll see we have 2 of our large day-long Excel events coming up, one in Denmark and one in San Diego. So if you're in either one of those locations, we hope that you'll come on down and spend the day with us. Liquidware is going to be at our San Diego event next week, and I'll be there too. So if you're in the area, please come visit. And finally, if some of you may have opted in to potentially win a Nintendo Switch Lite. So if you did so, we will announce the winner offline. We'll announce on Twitter. So be sure to follow us, follow my CUGC, and we'll announce the winner as soon as we find out who that is. But following us on Twitter is also a good way to just stay up to date on everything that's going on at CUGC, all of our local events and webinars like this one, our blogs, everything that we have going on. We tweet about it all the time, so make sure you follow us and come visit us at mycugc.org as well. We've got lots of discussion forums. If you've got Citrix related questions, there's lots of people there that can help you out. There's case studies, people with real world advice. So that is what we have for today. So thank you again, Matt. I appreciate you spending your time with us today. And thank you, Bart, for volunteering to moderate for us today and keeping an eye on those questions for us.
All right. Thank you, Stephanie. Thank you, Bart. It's a pleasure to be here. And thank you to all the attendees for jumping on. I know you guys are busy. I know this is right after lunch, so I was trying to keep you awake. And thank you very much for all the questions.
All right, guys. I hope you all have a great rest of your day and see you on mycugc.org again soon. Bye.
Thanks, guys. Bye.